Okay, we're going to start with a brief bit of notes on the Pythagorean theorem, and we're just going to review it because we're going to be using it coming forward. So the Pythagorean theorem is a squared plus b squared equals c squared. And with this we can find the side of any right angle triangle. So if this is 90 degrees, C would always be your hypotenuse, or the longest side, and the longest side is always opposite the 90-degree angle. And then A and B can be either of the other sides. It doesn't really matter. And so all we do is rearrange to find what we need. So we start with Pythagorean theorem. A squared equals b squared plus c squared. So in this case we have a and b and we're looking for c. So 5 squared plus 3 squared equals c squared. So that'd be 25 plus 9 equals c squared. And then we square root both. So we cancel that out and we get c. And the square root of 25 plus 9 is 5.8 meters. So C equals 5.8 meters. So let's look at the next triangle. So again, we're looking for C. We have A and B. A squared plus B squared equals C squared. So you have 3 squared plus 4 squared equals C squared. So you'll have 9 plus 16 equals c squared. Take the square root of both sides, and you get that c equals 5 meters. And this, the 3, 4, 5 Pythagoras triangle is quite a quote-unquote famous triangle in math. And sometimes we'll be given c, and we have to rearrange to find the other length. So in this case we have c, we'll call this b, and we're looking for a. So a squared plus b squared equals c squared. Now we need to get a by itself. So if a squared equals, we'll subtract b squared from both sides. So we have c squared minus b squared. And so then a squared will equal 6 squared minus 3 squared. You square root both sides, so a will equal the square root of 36 minus 9, and a equals 5.2 meters. So Pythagoras is just using algebra. You always start with a squared plus b squared equals c squared, and then just rearrange for what you want. A and B, it can be either side, it doesn't matter, but c squared always has to be the hypotenuse, which is the longest side, which is across from or opposite from the 90-degree angle. Okay, so if you're ever doing this and you find, say in this triangle we were given, you know, that this is 4 and this is 3, and you found out that this was 2 as the hypotenuse, that's wrong, because your hypotenuse has to be the longest side. So I'm going to get you to work on this worksheet on triangles. It's just a little bit of extra practice, and then we'll move on to the next section. So we're going to continue in the section 2.2 surface area, and this is why we just reviewed Pythagoras, because we need Pythagoras when we're working with the surface area of three-dimensional objects. So we have to recall that surface area is the number of square units needed to cover a three-dimensional object. So, or it's the sum of the areas of all the faces of an object. So let's say you had a box and it had a present in it, and you wanted to wrap the present. You would need enough wrapping paper to cover the entire box. So then it would be the area of all faces. So in the terms of a box, you'd have the face, so 1, 2, 3, 4, 5, 6. So it would be, the surface area would be the area of each of those faces added together. And again, check out your data pages for the surface area. There's lots of 3D objects. You're provided with the formulas, so you don't have to memorize them. You just have to be able to match the correct shape with the correct formula. So our first example will be a right cone. Okay, so this is sort of like an ice cream cone. Has a diameter of 27 centimeters. So diameter will be 27 centimeters. And a slant height of 40 centimeters. So slant height equals 40 centimeters. We're going to express our answer in the nearest tenth of a square centimeter. Okay, so square centimeters. And tenth, it will be a number with 1 decimal. Okay, so that's our tenth. It'll be 1 decimal. So first let's draw it. So let's draw our right cone. So it's just like a triangle with a circle. So like a party hat or like an ice cream cone. Here's our slant height, and that equals 40 centimeters. And then here's our diameter. So it's the entire length, and D equals 27 centimeters. And so we remember that radius is 1/2 of D. So our radius for this triangle is 1/2 of 27, or go up there, radius equals 13.5 centimeters. We need radius because our surface area formulas work with radius. So our formula is SA, so the surface area of a right cone equals the area of the side plus the area of the base. Okay, so the base would be the circle. Okay, so like the, if it's a party hat, the part that goes on your head, and then the side would be the actual cone part. And so we have pi times radius times slant height plus pi times radius squared. So we have pi. We figured out that radius is 13.5. We were told that slant height is 40. And again, we slot in our radius. And remember to use the pi button on your calculator, not 3.14. So you have 16.9, sorry, 1,696.46 plus 572.56. And we end up with 2,269, and we want to the nearest tenth, and that would be to 0 centimeters squared. And that's our surface area. Okay, and the squared belongs to the radius. So you do 13.5 squared, then multiply by pi. So let's look at a right pyramid. A right pyramid has a rectangular base, so this is just like the pyramids in Egypt. They're right pyramids. So the base is 16 centimeters by 20 centimeters. So there's 16 centimeters by 20 centimeters. Okay, and the slant height, which comes down in the middle here, it's at a right angle. And there's your slant height. Okay, so the slant height of the triangular face with the shorter base, so the shorter base would be 16, is 18 centimeters. And with the longer base, it's 17 centimeters. And the base is this square that you can see outlined at the bottom. So if you're thinking of the pyramids in Egypt, the base is the part that sits on the ground. Oh, so sorry, this is just going to sorry, I'm just reconfiguring the screen. Just 1 second. Okay, sorry about that. Let's keep going. So we're going to find the sum of all the areas of the faces. Okay, so we have to do the area of the base, and the base is just a rectangle, so that will be length times width, and the area of the triangles. So an area of a triangle is 1/2 times base times slant height. Okay, so we can either draw a net or draw each face. So a net would be if we kind of dissect the triangle and take down all its parts and lay it out flat. So instead of being 3D, we're going to make it 2D. Oh. Okay, and then so we'll have 16 by 20. It'll be 17 and 18. Okay, and here's, this will be triangle number 1 and triangle number 2. And there'll be 2 of each type of triangle. Okay, or we can draw each face. So we can draw the base, which is just a rectangle, and the area equals length times width. We're going to have 2 triangles, and we'll do number 1. So our number 1 triangle has a base of 20 and a slant height of 17. And then we have 2 triangles that are number 2. And this slant height equals 18. And the base equals 16. Okay, and then we can figure out the area for each of those. So I'll do it here. So the surface area equals the area of the base plus 2 times the area of triangle 1 plus 2 times the area of triangle 2. So the base is length times width, so that would be 16 times 20 plus 2 times 1/2 and then times 16. Oh, sorry. Triangle 1 is 17 and 20. 17 times 20 plus 2 times 1/2, 16 times 18. Okay, and you'll notice that the 2 and the 1/2 cancel out. Or you can leave them in there while you do the calculations, and you'll end up with 948 centimeters squared, because it's surface area. And there you go. So now let's try a cylinder. So a cylinder is like a pop can, or like a tube of some sort. So we're told that the radius is 3 centimeters, r equals 3 centimeters, and the height equals 5 centimeters. And if we look in our formula sheet, we'll find that the surface area of a cylinder equals 2 pi r squared plus 2 pi rh. So it will be 2 pi times 3 squared plus 2 pi times 3 times 5. Remember that the squared belongs just to the 3. So it'll be 2 pi times 9. Remember to use your pi key. So we end up with 56.549 plus 94.248, and we'll get 150.8 centimeters squared. And that's surface area. Again, square up your answer. Okay, and then here's a sphere. A sphere is just a 3D circle, so like a beach ball. And you can tell it's 3D because we'll put a dotted line in there to give it some depth. We know that our radius is 7 millimeters. And again, if you check out your formula sheet, you'll see that the surface area of a sphere equals 4 pi r squared. So for all of these, or for most of these, we really just need our radius. And we're usually just given it as radius. Sometimes we're given as diameter. We just divide by 2. So we'll have 4 pi times 49, because the squared belongs to the 7. And that will give us 615.8 millimeters squared. Okay, and so you'll be able to do part 1 of the worksheet. And we'll just do a little bit more, and that will be it for today. So the surface area for finding dimensions. So sometimes we're not asked to calculate the surface area. Sometimes we're looking for a dimension, so like a side or a radius or something like that. And so sometimes we're asked to calculate the surface area, but we're not given the dimensions. Okay, so basically what we'll have to do is rearrange using algebra to find what we need. So finding a dimension when the surface area is known. So the surface area of a varies from 459.96 centimeters squared to 506.71 centimeters squared. And this makes sense because some bowling balls are smaller than others. What is the variation in the diameter? So we've told the surface area, but now we want the diameter. So which shape is a bowling ball? On our formula sheet, a bowling ball is a ball, so it's a sphere. And the surface area is given as 4 pi r squared. Or we can also use pi d squared. Now since we have, or we're looking for diameter, I'm going to use this one here, pi d squared, because we are looking for diameter, and this has diameter in it. So that's just one less step for us. So we'll use this as ball number 1, and this as ball number 2. So we're going to substitute the value for SA into the formula and solve for D. So for ball number 1, the surface area equals 459.96. And ball number 2, surface area equals 506.71 centimeters squared. So if we have surface area equals pi d squared, we'll rearrange to get d by itself. So I'll divide both sides by pi. So surface area divided by pi equals d squared. And then we'll square root to get d by itself. So we'll end up with d equals the square root of surface area over pi. So we'll do ball 1 first, and then we'll do ball 2. So d equals, we know the surface area is 459.96 divided by pi. So d will be 12.1 centimeters, the diameter of 1. And then over here we can use the exact same equation because we're looking for the same thing. So we'll have the square root of 506.71 over pi. We'll get that d equals 12.7 centimeters. So then what do they vary? So the diameter of bowling balls varies from 12.1 centimeters to 12.7 centimeters. Okay, so that's the last question we're going to do for today. Please make sure you come Thursday at 10 a.m. for our in-class lesson. We have not had any in-class lessons, and it's really important that we get started. So come Thursday, bring all the worksheets you've been working on, bring any questions you might have. We're going to review what we've done. I'm going to have you write a couple short quizzes, and then we're going to get started on Thursday's lesson. Okay, please email me if you're having any problems. Otherwise, I will see you Thursday at 10 a.m.